Parallel circuit, question 3. In this circuit, we have a battery of 40 ohms powering two resistors, one at 6 ohms, the other one unknown. We also have two voltage drops, V1 and V2, which are unknown. The total current running through this circuit is 10 amps. Now, with our knowledge of parallel circuits, we know that the voltage drop has to be the same across each of the paths. Therefore, the voltage at 1 would be the same as the voltage at the battery. So therefore, it's 40 volts. That's the same for V2. Both those answers would be 40 volts. Now this third question is a little bit more involved. We want to know what the resistance is at this path. Through R2, the resistance we will need to calculate. However, we can figure out the total resistance of the circuit by knowing the total voltage and the total current. So recall from before that the total resistance of a circuit is equal to the total voltage divided by the total current. In this case, 40 volts will be divided by 10 amps to provide us with 4 ohms of resistance. We also know that in a parallel circuit, 1 over RT is equal to 1 over R1 plus 1 over R2. Given these, if we're looking for, this case, R2, we can rearrange the formula to give us 1 over R2 is equal to 1 over RT minus 1 over R1. Substituting in the values, knowing that the total resistance was 4 and the resistor R1 was 6, we can solve this by going 1 over R2 is equal to 1 over 4 minus 1 over 6. By using our calculator, subtract 1/4 minus 1/6, and then taking the reciprocal of it, we find that the value of the resistor R2 must be 12 ohms.